Hi everyone, this lesson is about finding the inverse of a 3 by 3 matrix. So I have a 3 by 3 matrix here, and the goal is of course to find the inverse. Now the first thing to do is to find the determinant of the matrix, because of course if the determinant is 0 it means it's a singular matrix and there is no inverse. So the determinant, usually what we will do with the determinant is we will look across the top row there, and we will first of all think of that first element there, 1, and we will isolate the row and the column that belong there. Now we always go positive first and then the value of the element 1, and then we find the determinant of the minor matrix, the one that's left here. So 1 by 2 is 2, subtract 4 by 5, which is, try that again, 4 by 5 is 20. Now the second entry, let's just take away the highlight there. The second entry is a 2, so it's always a negative for the second one, so it's a positive first and a negative second. And we isolate the row and the column that belong to that 2, and we look at the determinant of the minor matrix that remains. So by that we mean minus 1 multiplied by 2, that's negative 2, subtract 3 by 5, that's 15. Now the third one is plus. It always alternates positive, then negative, then positive. And let me just take away the highlight. So this time we're looking at the number 3, which will isolate the first row and the third column. So the element is 3, and now the determinant of the minor matrix is negative 4 subtract 3. Negative 4 subtract 3. So let's calculate this out. 2 take 20 is negative 18, and by 1 is still negative 18. Negative 2 subtract 15 is negative 17. Now multiply by negative becomes positive, and 2 17s are 34. Then 4 by 7, 4 subtract 3, negative 7, what am I saying? 3 times that is negative 21. So we have got here how much? Negative 18 plus 34, that would be negative 6, positive 16, subtract 21 is negative 5. Well, that's not 0. So the determinant of matrix A does not equal 0. This implies that the inverse of matrix A exists. So now the job is to find the inverse of matrix A. Just take that highlight away there. Well, in order to find the inverse of matrix A, we will apply the following rule. 1 divided by the determinant of matrix A multiplied by the transpose of the cofactor matrix. So the cofactor matrix, that's an interesting creature. Let's go. Well, we already know the determinant is negative 5, so that's not such a problem. But the cofactor matrix, well, let's see. Give ourselves plenty of space here. The cofactor matrix is going to be a matrix of minors, and each of the minors is a determinant of the 2 by 2 matrix that remains when we isolate the particular element we're talking about. So I'm just getting this sorted. And don't forget that it's still a transpose. So the cofactor matrix has alternating positive and negatives. It's like a checkerboard pattern. And then each of these little parallel lines, that's a matrix of minors. Now across the first row it's going to be the same as we did last time. You see the first element up here, we isolate the row and the column belonging to that element, and it's literally the determinant of the 2 by 2 matrix 1, 5, 4, 2. Then if I was to look at the second element in the first row, the remaining minor matrix is negative 1, 5, 3, 2. And so on and so on. Now let me just pause for a moment while I finish typing all this in. So there's all of the matrices, the 2 by 2 minor matrices. So we end up with 1 over 5. Now remember, for each of these 2 by 2s, it would be A times D subtract B by C. In the first case, that would make it 2 subtract 20. So we would have negative 18, 17, negative 7, 8, negative 7, 2, 7, negative 8, 3. And don't forget, we need the transpose of that. So that matrix there, that 3 by 3 matrix, is the cofactor matrix. And now I just need to do the transpose of that, and I need to multiply through by the factor 1 over negative 5. So if I do the transpose of that, remember the first row becomes the first column. So it's negative 18, then 17, then negative 7. Now multiplying through by the factor of, it would mean divide by minus 5, divide by minus 5. The second row, 8, negative 7, 2, that last one's a 2. And then all of that divided by minus 5. And then the third row, 7, negative 8, 3. And all divided by negative 5. So that's both the transpose and the scalar multiple. And finally, writing this in simplified form, we get 3.6, negative 1.6, negative 1.4, negative 3.4, 1.4, 1.6, 1.4, negative 0.4, and negative 0.6. Now that's the inverse of matrix A. Of course, you can check that we've got the correct solution by taking the original matrix A, multiply by this, and seeing that we get the identity matrix. Okay, that's it for this time. Thanks for watching.